Okay, this video is about correlations. Correlations are relatively simple to understand, but at the same time, they're also the most commonly misinterpreted statistical test that we can run. So consider this. Would you agree that people who study more tend to get good grades? Would you agree that people who run marathons as a hobby tend to be skinny? Would you agree that people who feel supported at work tend to be satisfied with their jobs? So what all these mean? If we think that that might be true, that people who study more tend to get better grades, and people who run a lot tend to be skinny, and if you feel supported at work, you tend to be satisfied with the job. Those are things that might be correlated to one another. So to determine that, we have to be able to measure all these and see how well they are correlated. So the attributes of those are correlations are used to show how two sets of data are related to one another. And most people understand that concept that two pieces of information can be related. What they don't get is this. It's just because these two pieces of information are related, that does not indicate a cause and effect relationship. This is the thing that people don't get. It's just because I run a marathon, that doesn't mean I'm going to be skinny. There's a relationship between the two things. And once again, the data matters. The kind of correlation we conduct with interval and ratio data is different than ordinal data. So if you go back to your table of selecting a statistical test, what you'll notice for interval data is there's something called a Pearson test. And for ordinal data or non-normal distributions for a correlation is called a Spearman's test. And they matter. They're two different tests. They do two different things. They give us the same kind of data in terms of an output, but they're running different tests. So how do we do this? Well, let's say hypothetically I'm collecting information about the years of experience somebody has and the income that they earn in terms of the thousands of dollars. So this is person has no experience is earning $20,000. Here's person number 2, 5 years earning $30,000. So the question is, what kind of information is included? Well, it's years of experience and its incomes in thousands. What form does it occur? And that what we mean by that come from a range of numbers, or yours appear to be yes, no. Well, this is ratio data. This is interval data. So this is something we're going to run with Pearson. So really, that's the only two things we can compare. So we look, push the data, or push the data in, punch a couple of buttons, and we get this. This is a scattergram. It shows the relationship between years of experience and income. And what we will see is there is a positive relationship to that. This line, if you remember from math class, is called the line of best fit. It is a descriptive indicator of the relationship to these two things. So it's fairly positive. And you'll notice that some of them are on this side of the line, and some are on this side of the line. Well, it's not a perfect model because of the variance in the numbers. So it's a visual representation. But we want to know more than that. We want to be able to get more information from that. So we get a number called an R value, which is in this case is 0.858. So this line is at a scale of 0.858. We also need to know whether or not this is a significant relationship. Some correlations can be very strong but not be significant. That means we don't have much confidence in it. This number is something called explained variance. So the relationship between years of experience and income, 74% of that relationship in terms of how much income somebody makes can be defined by the years of experience, but some of it can't. So again, this is the correlation coefficient. If you square that number, you get that. That is the explained variance. That tells us how much income somebody makes is based on or is related to how many years of experience they have. The opposite of this, the 0.26, is the unexplained variance. That means that how much money somebody makes doesn't have anything to do with years of experience. It has something to do with something either we didn't measure or we don't even know. So let's go back to these. Studying grades. Is there other factors that go into the grades that somebody gets? Are there other factors that influence how much somebody weighs? Are there other factors that indicate job satisfaction? In other words, is the first variable the only thing that influences the second? No, there's not. There's other things that affect this. So on this part explains 74% of this part if this was tied to that. What explains the grades that we don't know is the unexplained variance. So correlations run on a scale from -1, which is a perfect negative correlation, to a +1. And when there's no correlation between these two things, there is a 0. So for example, how much you smoke and your lifespan tend to have a negative relationship. The more you smoke, the less you're going to live. High school rank and college success tend to have a positive correlation. The higher you are in your class rank in high school, the more likely you are to be successful in college. And we probably think that one doesn't have anything to do with the other. Of course, you try having that one and see how well this works out. But in theory, that's the way that's supposed to be. So what do these look like? Well, here's another correlation between height and weight. Again, you'll see the numbers or the points on here are all over the place. Because yes, height does in some ways describe how much somebody weighs, but there are other things that influence that. That's not always it. Another example. This is our weight. This is how much we run per week. So the more I run, the less I weigh. Now here's something I hear called an outlier. So if you ever talk to somebody about a correlation and you say, well, this tends to be correlated with that. They say, well, I know a person who runs all the time and he weighs 90 kilograms. Well, this isn't a perfect model. There are things called outliers on it, but in general, we're trying to describe this. So let's look at some of these other examples. What you'll see on the following slides is several representations. There's a strong negative correlation, no correlation, strong positive, weak negative, weak positive. Oops, I got those backwards. Well, we'll go ahead and talk about this real quick. So let's talk about what is a strong correlation versus a weak. And you want to hang on to this. A small correlation is anywhere from 0.1 to 0.29. A medium correlation is 0.3 to 0.49. And a large correlation is 0.5 to 1. And remember, the negative of these is the same thing. It's just a negative. You can have a small negative correlation, a medium negative correlation and a large negative correlation. Just because they're negative, that doesn't mean that they're exclusive of small, medium, and large. So here's what these might look like. It's for a perfect positive correlation. All your data points fall on the line. For no correlation, there won't be any pattern to it at all. Negative correlation, they're all on the line. When it's a moderate correlation, there tends to be a line of best fit, but your data points don't tend to line up on it. Same thing with the negative correlation. So what do these look like? This is a correlation table. And when you look at data output, you'll see something like this. So this is a correlation between some factors about alumni relations, including motivation, visibility, brand loyalty, which means that you're loyal to your university, the perceived quality of your experience, something they call special characteristics in advertising. And what this shows is which of these are correlated. So there is a small correlation between advertising and motivation, but it is significant. What I want you to notice is here's another correlation between alumni visibility and motivation. It's not significant. Alumni visibility, perceived quality, it's a little bit stronger correlation, it's significant, but these other ones aren't. So everywhere you see an asterisk, that's a significant correlation. Just because you have similar numbers, for example, here and here, this is a stronger correlation, but it's not significant. The other thing that you'll notice is this area up here is a mirror image of this area down here, because the correlation between alumni visibility and motivation is the same as the correlation between the motivation and alumni visibility. So very often this will be removed. Here's my favorite correlation. This is the correlation between global average temperature and the number of pirates in the world. And what you'll see is years ago, there was about, in 1820, it's estimated to be 35,000 pirates in the world. And the average global temperature in Celsius was about 14.25 degrees. So as time has gone by, we have less and less pirates, and the global average temperature has gone up. So by some people's rationalization, the way to fix the global temperature problem is to introduce more pirates. That's because some people think that this is a cause and effect relationship. It's not. There's just two data points can be related. That doesn't mean that one has anything to do with another. And really, you can take just about any two sets of data and you'll find a correlation between them. It's very rare to find a zero correlation. That doesn't mean that there's anything happening. So here's some other examples. There is a positive correlation between ice cream consumption and drowning, ice cream consumption and murder, ice cream consumption and boating accidents, ice cream consumption and shark attacks. Well, that doesn't mean that if you eat ice cream, you're going to drown. If you eat ice cream, you're going to get murdered. What this means is those are covariates. There is something else related to these things that we're not taking into account. And it turns out you eat ice cream in the summer. You eat more ice cream in the summer. And when it's the summer, you're more likely to be swimming. You're more likely to be boating. You're more likely to be in the ocean. I never have really figured out the one about the murder. I guess it's hot and you don't get enough ice cream and you just kind of lose it on somebody. And that's the result of it. But those are covariates. It's those other factors at play that influence the correlations. And if we don't control for them, then we cannot explain what the correlation is about. That's why R2, the explained variance, is valuable. So I'm going to provide an example of these and then also a short exercise for you to work through.